Welcome back, Precalcsters. About half of you guys heard my joke a second ago. Do you guys know who Bruce Lee was?
Yeah.
Martial artist. There's a lot of really fun stories about Bruce Lee. Any idea what his favorite drink was?
Orange juice.
What? Yeah. All right. Why orange juice? Just out of curiosity. Okay, that's fair. Water with an obnoxious pronunciation is the correct answer. So here we go. We are looking today, and we're going to get through as much of it as we can. We're looking at 3.2. Don't like the way that 3 looks, so we're going to fix it. 3.2. And in 3.2, our entire focus, you're going to see me write this word one time. One time. 3.2, our focus is on the idea of what we call logarithmic functions. And their graphs. Okay. Quick check, because I know you guys have seen logarithms before. Is there a shorthand that's accepted like everywhere? Log. Just log. Cool. So right off the bat, instead of ever writing logarithmic again, unless like there's a specific reason I will, we're just going to talk about log functions. So log and functions. Now, right off the bat, you guys have seen logarithms before. I'm certain of it. Who here thinks they remember what a logarithm is? And that's okay. Maybe somebody does. It looked like maybe, Rafa, you were going to make a comment, but I can't tell for sure. The opposite of an exponential. Now, you do not have to jot this down again, but remember last section we were looking at exponential functions, and they look like this. Roughly. That's exponential growth. They could be decay. But quick check, if I take this line, and man, am I getting better at using this. How many times do I touch the function here and 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 here? Once. This means this function is injective, or one-to-one. For every one y value, there's one x value. This is something we've talked about earlier this year. The fact that this is one-to-one means that what exists? It's inverse. Now, more specifically, you're absolutely right, but I want to be a little bit more specific. The inverse function also exists. So, without doing, we'll talk about the graph part of it when we get to it, but Rafa said a second ago, it's the opposite of a exponential. 100% I agree with you. We're going to sneak into that. So, here we go. Right off the bat, let's define this. So, we're just going to go ahead and, I lied, I am going to write it again. It's up to you if you just write log or not. A logarithm. Okay. While we look at this, our logarithm, we're going to get purely a mathy definition. As we go through, check it out. We need to set some ground activities first, or hypotheses first. So let's say we get the following. 4, and we're going to require that we get a positive x value. So we're going to have an x greater than 0. But we also need an a value greater than 0. And finally, we're going to say that a can't be 1. So we have a few little pieces worked out here. X is positive, a is positive, and not equal to 1. Here we go. The definition of a log. Here it is. We're told the following. Y is equal to, and I'm going to write this out, and I'm going to see if anybody remembers how to read this. What did I just say that y is equal to? So I like where your head's at. I heard log sub a. This is going to change a little bit, and we'll make it sure we have it. This is read log base a of x. Okay. Notice the of part tells me that this is like its own little piece, just like trig stuff is. Sine of x or theta, whatever it is, that's one piece. Log base a of x is one piece. Now, they're just numbers, so we'll make sure we get experience with this. I'm going to expand one little tiny bit. Where x, in this case, is the... Anybody recall what I refer to those pieces as? Like f of 5, I call the 5 the something of f. The argument. Okay. So we get some language in the way that we talk about it. Log base a of x, x is called the argument. Now, whether you have parentheses or not, if it's just one simple argument, doesn't matter. But we'll deal with that as it comes. Okay, here's the other part of our definition. Y is equal to log base a of x if and only if. And here we go. What is the base of this? A, so check it out. A, and this is the only weird part. Everybody wants to try to think of x as the exponent because it looks like it is, right? A subscript and a normal one, but the size difference should tell you no because exponents are always smaller. When we use a log, we switch sides. A to the power of y is equal to x. All right. Going through this, there is nothing that we can say that's any different. It's just a definition. This is just the rule. We don't even have to say logic about it because, again, it's just the rule, just a definition. So what logarithms do for us right now is they essentially allow us to move between two different forms. And maybe that doesn't make a ton of sense as to why we would care yet, but let's get a little bit of practice. So right off the bat, we're going to do an example where we are asked to evaluate. And we'll look at a couple, and we'll see that we can actually make sense of these things pretty quickly. So I'm going to do a couple examples where they're going to be written slightly different. Let's say that we have a function that is f of x, and I'm told that it's log base 2 of x. I don't know why my L would change there. Log base 2 of x. Okay. I want us to find on this problem f of, let's say 64. Right off the bat. Now, some of you may be comfortable in doing this more than others. Some of you might have no idea. Anybody in here look at this and go, I don't remember even a little bit about any of this. And that's okay. If that's you, that's fine. No issues there. Check it out. If we just go step by step, I'm literally just going to replace any x with a what? 64. So here's how I would suggest thinking about this. I'm trying to find log base 2 of 64. That's the problem that we're at right now. Somebody in here might know it off the top of your head, but if you don't, that's all right. Can we all agree that even if we don't know it, that it's probably a number? Okay, I don't care what we call it right now. I don't know what the number is. Any preference on the choice that I use for some unknown? Say it again. So I'm not going to use a number. I think you're pretty close to being right, though. I don't recall off the top of my head. I'll have to look at it. Can I call it x if I don't know? I have no idea what it is. I'm just going to call it that for now. Okay, using the definition. And you don't have to write this. Now, applying the definition, if you need this extra little step here, and I'm going to use DEF apostrophe N for definition. If we just apply the definition that we have written above, I'm in log form right now, and it's kind of hard to think about. Is it super hard to think about exponential form, at least if they're nice? So let me rephrase that, because that's an odd question. It's easier to think in exponential form if they're nice than log form, because it's more natural. Okay, check it out. What's the base of this log? 2, and here's the hardest question. 2 to what power? Ooh, gotcha. It's not 64. Everybody wants it to be 64 because it looks like it, but notice. A to this power. So what's this power? X. And I know that this is just asking me to say, hey, 2 to the x equals 64 for some value of x. All we need to know is what that x is. That's the whole goal. Now, looking at it, we might be able to just think this one out without doing a ton of work, but we'll get up to some bigger ones. What's 2 to the third? Okay, what's 2 to the 2? 4. So 2 to the 3 is 8. 2 to the 4 should be 16. 2 to the 5 is, and 2 to the 6, 64. If you didn't catch it, I'm just multiplying by 2 one more time. I think then that we can say, hey, 2 to the x is equal to 2 to the 6. What do you notice about the bases? Oh my gosh, they're the same. And the one-to-one property says if the bases are same, like this, then I can just do what with them essentially? Get rid of them or drop them out, which means we just concluded that x must be equal to what? 6. Now, this is much more formal than I would normally do it. Quick check, those 3 dots, they're awesome. What do they stand for? Not quite. Therefore. Therefore, if we look at it, I'm going to say f of 64. What did we just determine it was equal to? So not 2 to the 6th, 6. Because 2 to the power of 6 is 64. And it's just a little back and forth kind of thought process. I want you guys to do one for me as well. Before just saying, hey, now you do one, anybody like, what questions do you have? That's a better way to ask it. Nobody got lost in that process. Cool. So B, I'm going to switch it up just a little bit here on you. I want you to solve for me log base 3 of 81. Evaluate this, log base 3 of 81. And I'll use my parentheses specifically. If you don't know what it is yet, maybe a placeholder would be convenient. I'm going to give you a minute, let you work through it. I would encourage you to try to write it as an exponential if you struggle to think about it. Right? I assume this is equal to a number. What do you want me to call the number? I don't know what it is yet. X is fine with me, which means our next step says 3 to which power? 3 to the x is equal to 81. Cool. Now, I'm okay with powers as long as they're not big. I believe that 81 is 3 times 27, or making it more specific, I think it's 3 to the 4. The second that I recognize this, we now have concluded in this particular problem that log base 3 of 81 is equal to what? 4. And I can even check this because, and I can look, 3 to the 4 is 81. Yep, I got it. I can verify that 3 times 3 times 3 times 3 does give me 81. We have it. Seem doable. Okay. So, when we learn to count, and we don't do this super often, but I think I've mentioned it. What's the biggest number you learned? So that's a weird way to word it. You start counting at 1. Most kids don't start at 0 because the concept of, oh, I'm holding up no fingers doesn't really mean anything. And that's fairly within the last couple thousand years. The idea of using 0 is a new idea mathematically. Most kids start to count at what number, though? 1. And in my head, I think that's natural, so I call them the natural numbers, which they are. The first big number that a kid learns to count to. 10 is the first one. Why 10? Most kids, almost every kid on earth, learns to count to 10 first. You got these things. Every single one of us have these 10 digits in common. Would you agree? With the exception of, like... something unfortunate. Yeah. Or something super awesome, like maybe you have a second opposable digit over here. That'd be so cool. Anyway, we all have that in common, yeah? So we're going to sneak in a definition here. In fact, it's so common that we are going to have what's known as the common log. Okay, the common logarithm. We don't have to say almost anything about this. We're just going to say it is log base 10. And this is a wordy version to write it. But a couple things I want to talk about. Log base 10 is a common log. When you write it, and I'm going to we'll make a little subsection, notation. So how do we talk about this? You would be completely correct if you use the following. You could write log base 10 of x. Or we can pick any number. I'm going to say 100 right now. What's the base? 10. And quick check, because I think we can all do this. Is there a power of 10, 10 to something, that equals 100? What is it? 2. because 10 to the power of 2 is 100. And I just, like, it's weird that we have to do this, but 10 to the 2 equals 100. It seems cumbersome and kind of clunky as you're doing it, but I promise the benefits of being able to do this are huge here in just a couple minutes. Okay. Alternatively, though, because we all agree that we, in common, have all 10 fingers, and it's so regular for people to count in powers of 10, like the entire metric system, check it out. More commonly, we just write this. These are the same expression. Because it's so common, I just don't have to write the base. If we see this is log 100, I'm fine with that. If I wanted to be wordier, the common base that we just don't need to write is what number? 10. So what's log 100? 2. Do me a favor, on your left side of your calculator, the fourth button from the bottom, what do you see written on it? Log. When you type it, it just says log, right? Log 100 better be equal to 2 when you type it in. Cool. Super handy to have. It gets wound up getting used in a variety of places. The base that works better than this, and it seems wonky, but E is a better base to use. And we'll see that in the coming days. Do we need practice with log 10? Find me, before we do it, I want to estimate log of 800. Don't type it in yet. Estimate it. So without typing it in, my question for you is, what is this? You're only going to give me a really rough approximation. 10 to the power of 16 is like 16 quadrillion. Too big. 160 quadrillion, sorry. Quintillion. I don't know, one of them. That's a much closer answer. 800 is between two powers of 10, I think. 10 to the 2 is what? 100. What's 10 to the 3? 10 to the 3 is 1,000, right? 10 times 10 times 10. Is 800 between 10 to the 2 and 10 to the 3? And it's a little bit closer to 10 to the 3, I think. I'm guessing. I haven't typed it in. I have no idea. 2.7, 2.6, somewhere in that range. What does it wind up to? Ah, I was way off. 2.9? Okay, so I was a bit off, but it's between 2 and 3. I knew that, and closer to 3. We can calculate base 10 relatively well, just as an estimate. Cool. I don't really want to talk about this anymore, but a couple for you. Don't type these in. I just want you to think about these, and we're going to see them in a second. What's log base 10 of 10? Gosh dang it. What's log of 10? Ooh, 10 to the 10? 1. Why? Because 10 to the 1 is 10. Okay? Couple more for you. I want the log of 1/10. -1. Why? 10 to the -1 equals 1/10. Language. Follow up. Log of 0. But 10 to the 0 is 1. Oh. It's not 0. It can't be 0. 10 to the 0 is 1. Oh my gosh. It doesn't exist. Check it out. We just added a new superpower to our mathematical abilities. Functions are not defined in 3 places all of a sudden. I can't divide by what number? 0. So I can't divide by 0. I can't, within the real numbers at least, take the square root of what type of number? Can't take the square root of a negative. Can't divide by 0. And all of a sudden, can you take the log of anything that's 0 or smaller? Are you ever going to make 10 to some power be 0? Not a chance. Will it get close? Like 10 to the -50 million is 1 over 10 to the 50 million. Almost 0, but not quite. Can you ever make 10 to some power a negative? I can't make something negative just by adding an exponent to it, right? 3 to the 5 is positive. 3 to the -5 is still positive. There's no negatives there. We have discovered a new hole or a new gap in domains as we get to them. Cool. That will come back. I just want to talk about it. Last one, just so I can write it. What's log of 1? Why? because 10 to the 0 is equal to 1. Cool. Quick reminder, what's this symbol? Nope. This is therefore. Because this is the case. All right. Now, there are some properties that we're going to use that are super valuable. So we're just going to make a little section, and this isn't a definition, but it's important enough that I'm writing in all caps. Log properties. Follow-up question. How proofy do you want to get? You guys didn't like proofs in geometry? They're 2-column proofs, right? You guys did, here's a statement, here's my reason, and whatnot, yeah? Would you like to see what proof looks like when, like, you don't have to write it down, but I think you'd find value in seeing that geometry proofs, if you hated them, 1, I think you're wrong. 2, however, they're not, like, proofs aren't always as bad as maybe the first initial flavor of proof that you get taught in geometry. We'll see. We might do a proof of this. Okay, some really, really handy properties. And in no particular order. Part 1. Log base A of 1, no matter what we pick for A to what power spits out a 1? 0. Now I'm going to say for all A greater than 0, but I'm going to use fancy notation. For all A greater than 0. We will not take the log of a negative number. It gets wonky, it gets weird, you have to mix in a whole bunch of imaginary stuff that gets crazy. We won't. What does this symbol mean? For all. Cool. If your argument's a 1, always 0. Piece of cake. Beyond that, throw you a curveball here. What's log base A of A? It's 1. If you're struggling to think about it, check it out. When you think about logs, and you're going to hear me say this about 1,000,000 times, A to what power gives me A? 1. The only one that possibly could work. Okay. Number 3. Ooh, how do I want to approach this? Nope, it's cool. This one comes in 2 varieties. If I say log base A of A to the X, this one's harder to think about. I want you and your neighbors to see if you can logic it out. It's nothing crazy, but it gets weird for a second. If you think you, so A to the A, I'd be wary. I don't like A necessarily. So I've added another property. They're the 2 sides of the same property. Log base A of A to the X and A to the power of log base A of X. So the second I change the wording here, anybody feel confident in this answer? This, okay, I don't believe you. I think somebody's confident, but I'm okay with that. Check it out. For that third property, the top line. So easy. A to what power gives me A to the X? It's obvious the second you change that language, right? A to the X gives me A to the X. Piece of cake. All right. Now, notice what just happened. At the very beginning, Rafa made a comment about an exponential and log undo each other. They're inverses. Notice I just took the log base A of an exponential with base A. When I do this, don't draw this on yours, but when you take something and its inverse and you compose them or put them together, they just fall out, right? Notice what essentially just happened. They just fell out. This is my inverse property that's going to be so powerful. Okay, beyond that, this one's harder to think about, but we have an exponential and a log. What's the base of my exponential? A, this is my exponential base. What is the base of the logarithm? A. And what do exponentials and logs do to each other? Cancel, cross, undo, whatever language you want to go with there. Which means if this happened just like the other one, what falls out of this? Boom. Super powerful property that until we saw this, there's probably, we'll be able to do problems that you wouldn't have been able to evaluate. Okay, the last one. I'm going to say log base A of x, and I'm going to pause here really quickly. The argument piece, those of you in physics, when we went through the trig stuff, you can or cannot use parentheses. It is up to you. If this is what I have written, even without parentheses, what's the argument of this logarithm? X is what would be in parentheses. You do not have to use them unless you have confusion or ambiguity on what your argument is. And I'll show you an example of that. I'm going to make the claim that log base A of x equals log base A of y. So same base, everything's the same. Log base A of y. If and only if, what do you think must be true? Same log, same base, different arguments. I claim they spit out the same number. What do you think we could conclude about the relationship between x and y? They're equal. This is that one-to-one property again. Okay. Boom. I want us to solve a couple logs real quick. Oh man, these problems get so cool so fast. Before moving on, the stuff that we've seen so far looks familiar or it looks brand new to you? Familiar-ish, at least some of it. Okay, so let's do an example then. Nothing too crazy. I'm going to move this one over so it's a little bit nicer in the notes. Cool. It's really hard for me to resist just going to the more challenging problems. But cool. So example, I want us to solve the followings. For the first, I want us to consider log of 4 minus 3x. And this one I do want to focus on before I even write the rest of the problem. I included parentheses there. What's the argument of this log? 4 minus 3x. What's the base of this log? 10. I want you to contrast. Don't write this one down. If I had written this like this instead, is it the same? In this situation, the parentheses here matter. If I don't write the parentheses, what's the only thing that I'm allowed to assume is connected to the log? 4, so it would look like this. These are not the same expression. Cool. All right. I'm going to make the claim, though, that log of 4 minus 3x is exactly equal to the log of x plus 2. Right off the bat. There are two logs, right, that are set equal. What's the base of both of them? And logs are one-to-one, or injective, which means the one-to-one property exists. Since they're both log base 10, what can I write on the next line immediately? 4 minus 3x must be equal to x plus 2. And what we've done here, this is property 4. 1-to-1. You do not have to include this annotation, but if you want it, you can. It's property 4 that we just listed. I want you guys to solve that for me real quick. I have faith in you. S-S-O-O-L-V-E. There's too many letters to do it the same way that you guys were doing it the other night, but worth a shot. Cool, love it. X is 1/2. Now, these problems with the concepts that we're talking about right now, the log stuff, I can't make a log problem, just the log part of it, any harder. Could I make a problem using this harder though? Like, check it out. I don't think we necessarily have to do this one unless you guys are just dying to, but that one-to-one property is a piece of cake. We can switch them up a little bit though. Like if I wanted to do log base pi of x squared plus 5x, and I said, oh, that's the same thing as log base pi of 3x cubed plus 4. Conceptually, it looks like a harder problem. The log part of it's no harder. Do the logs match? The bases match, which means the arguments must be equal, right? All of a sudden, I can test how well can you do log stuff, which pretty chill, I think. Less chill part about this problem, though, is trying to solve this. Now, whether we do it or not, I just made this problem up off the top of my head. I would bet that it's probably not a nice answer. If we wanted to solve it, though, what would we have to do? Set equal to 0, and then I see a PQ list coming up. Set equal to 0, and PQ list. Whoa, I don't like that Q. Would you like to run through a PQ list with this? I didn't check the answers at all. I don't really want to, just because I'm not convinced that it's going to be a nice answer. I don't think it's going to be nice. I bet I give you a PQ list problem at some point. It will happen. Conceptually, though, the log part of it, did it make it any harder? Not even a little bit. So, check it out. Oh my gosh, this stuff is so fun. I love it. Let's do some graphing. Cool. Everybody loves graphing. Everybody loves logarithms. So you're in for a treat. Those 4 properties that we listed, if you keep those 4, you're going to be, like, there's not going to be any issues moving forward. I really want to start solving stuff, but we're not quite there yet because we get a bunch more properties in our next section. That's fine. Cool. So we've talked about the definition and how to apply them. Let's do some graphing. Okay. Much like we saw with the exponential stuff, it's weird because I can't give you a number to use as a base. We just have to say, look, here's a general number A or B, whatever we want to use. B is a more natural choice for me. Your book uses A. I want us to consider the parent. If we look at the parent function, I think the easiest possible function that we could graph would be log base. Anybody opposed if I make the switch to B? B for base makes more sense to me. This is the simplest log function that you could possibly graph. Log base B of x. Okay. Now, going through this, the table here always feels wonky when people start graphing logs. If I said it was 2 or b to the x instead, could you tell me what b to the 1 and b to the 0 and b to the negative 1 are? There's a lot of language there. I'm just going to check. Now that it's a white background, we need a new color to alliterate with. So before it was, if it's white, don't write, or if it's gray, put the pencil away. I don't know that you can still see gray though. Kind of. Anyway, check it out. I'm just going to use, gosh, there's got to be a color here that I don't like. Can you guys see this? Nope, hate it. Hate it, hate it. We'll just have to start specifying. If it's, nope, nothing rhymes with orange. Check it out. If I said, hey, b to the x, could you tell me b to the 1? B. How about b to the 0? How about b to the negative 1? 1b, right? Or 1 over b. Cool. That idea will apply exactly the same here. We're going to make a little table. X log base b of x and the f of x or the y value that it spits out. Now, when we start graphing these, I'll have like more specific stuff that will align with like an actual problem that we're doing. But let's check this out. This looks like it could be challenging. Right off the bat. Give me a power of b that's easy for you to think of in your head. B to the 1 is really easy, right? What's b to the 1? So check this out. If I pick the point B, let's just see what happens. This would turn into log base b of b. And it's ugly and it sounds redundant, but I promise this is going to pay off. What is log base b of b? 1. Because b to the power of 1 equals b. What if, hypothetically, I wanted it to be a 1? Find me log base b of 1. Abigail confidently whispers, or at least mouths, I didn't hear any noise come out, 0. Do you guys agree with that? Gosh, there's one more. What if I wanted it to be 1/b? Log base b of 1 over b. Good. Riley says -1. And it's because b to the power of -1 gives me 1 over b. Now, do me a favor really quickly. Check back in your notes, which, as long as you took notes from the video, we did something similar with a to the x. Check the points that we got when we did a to the x. I think we got 1 comma a, we got 0 comma 1, and we had -1 comma 1 over a. Do these points look similar? Literally, they just switched places, right? It's like they've undone each other, or gosh, it's like they're inverses. This turns out happening every single time. When we're graphing, here is my suggestion. We're going to graph things that get uglier than this, just so you know. But as long as we follow just this one simple rule, this will get easy. I'm going to wait until Kalisha's back because this is important enough that it's going to help everybody. I want you guys to really roughly for me graph, and this is a weird idea, I want you to graph log base b of x. And there's an issue, and you're going to find that issue pretty quickly. Here's x, and here's f of x or y. I want you guys to try to graph this. It's super general. There's no numbers, which make it weird. There's numbers on the y-axis, I guess. 1, -1, that's a piece of cake. I want to see what you guys come up with. If it would help, you are cool. Like, you're not gonna be able to put real nice numbers here because we don't know what b is. If it'll help make it easier, replace b with 2. That makes it pretty easy. 1, 0, 2, 1, and 1/2 and -1. Those are easy points to graph. If I do it with b, it looks exactly like it would with 2, right? If I plug in log base 2 of 1, I would get the point 2, 0, which this is just b, some arbitrary number. If I do log base 2 of 2, I get 1. Sorry. Yeah, so there it is. I think I pointed at the wrong point before. Did I confuse everybody just now? Because I confused me as I wrote it, because I pointed at the wrong point. All right, let's think about it with 2. If I replace this with a 2, log base 2, and you don't have to write this, I just want to think about it. What's log base 2 of 1? 2 to what power gives me 1? So I would get the point 1, 0, which is on my graph, right? What if I wanted to do, I don't know, 2. What's log base 2 of 2? So here's the point 2 comma 1, or b, if we just use b. What if I wanted to do 1/2? Log base 2 of 1/2. So here's the point 1 over b and -1. Now, with these, if I think to like way further, and you don't have to do this, but since I have the 1 over 2 example and I'm using base 2, what if I did 1 over 64? Or even easier, 2 to the -6 we decided. Or 1 over 2 to the 6, I'm sorry. What's log base 2 of 1 over 2 to the 6th? Almost. -6. If I had put that point, it'd be like way over here and down here. Am I ever going to quite get to 0? No. Which means if I'm never going to quite get to 0, I get really close, but I never touch it. That has a name. Asymptote. So we're going to make 2 important comments now that you're back. I waited. Check it out. These points, and then we'll come back to this graph. Every log function you ever graph, I have 2 huge pieces of advice. There is a vertical asymptote every single time at the x that makes the argument equal to 0. And I'm going to shorthand argument in the future with arg. Argument equal to 0. Whatever it happens to be. And our arguments can get ugly and gross. That's fine. Doesn't change anything. Just set the argument equal to 0 and you get the asymptote. Beyond that, we're also going to choose x values according to the base. Now, I'm going to expand on that. But we're choosing x values to plug in that align with the base and make stuff easy. So notice, the base was b, right? I picked numbers very specifically, so I knew it would be b to the 0, b to the 1, and b to the -1, because those are all the easiest places. As I'm looking at this, the way that we're going to do it if the problem gets harder is x, you're going to find these by set argument equal to, and there's 3 values that we're going to set it equal to. Base, or yeah, we'll do base, whatever it is, 1, and 1 over the base. 3 points is all it takes for every single log. You're going to set the argument equal to the base, to 1, and to 1 over the base every single time. Now, it might get uglier, and we'll do an ugly one here today or tomorrow, but every single time this is going to happen. Cool. All right, back to this graph. What value of x makes this argument 0? Say that again. I don't agree with you. It's such a weird question. What value of x makes, what is my argument right now on this function? So what value of x makes x 0? 0. And it's a weird question. I'm going to stick with purple for my asymptote. Here it is. I'm never going to touch it. Never. Which means if I now graph this, look at that beautiful logarithm. Awesome. This is how logs look. Seem doable. We're going to do one hard one together, and then I'll probably give you some assignment to start tonight. We may not finish the whole assignment, though. Although we're pretty close to finishing the whole assignment. Does this feel hard right now? Let's make it feel harder. Okay. Notice, I didn't say let's make it harder. I said let's make it feel harder. It's not really going to be any harder, I promise. But we're going to do an ugly one together. Example, I want you to graph, not sketch. Then, beyond just graphing, I want us to state the domain and range. Dom and ran. Cool. We should do an awful one first, right? Good. So here we go. F of x equals, I want to graph 2 log base 3 x plus 4 minus 1. It looks so bad. Do you think it really is? You're wrong. It's not bad. It might, like, that's subjective, right? I can't really say that you're wrong. But I promise, as bad as it looks, if you just follow my patented 3-point method, I didn't patent it, that's a lie, just for the record. It's a piece of cake. Don't use your calculator to graph it. I'll show you guys how to do it, but I don't care if your calculator can do it. I care if you can do it. Okay, we're going to break this down more than I normally do. Couple statements. Number, don't have my random calculator. Who haven't I heard from today? Ken, what's the base of this log? The base is 3. I agree with you. I'm going to make note of that. Okay, the argument, Sean, is what? If you can identify those two things, graphing these is a piece of cake. Do you want to do the asymptote before we do the points, or do you want to do the points first and then do the asymptote? Points first? It doesn't really matter, right? They're going to be the same either way. Let's check it out. I'm going to start making my table with the understanding that I'm going to need a little bit of scratch work. 2 log base 3 of x plus 4 minus 1 f of x. And then are you guys able to, on your page, you didn't have to switch pages just now. You still have all that other stuff. Cool. Here's my table. I'm going to do a little bit of scratch work over here. Oh my gosh, the grid is off and it's going to drive me crazy. All right. Dang it. Well, I know the base and I know the argument. A moment ago I said, hey, to choose your x values, let's do this. I'm going to set my argument equal to 3 different things. And I'm going to use 3 different colors if possible. X plus 4 is my argument. What is the first thing I told you to make it equal to? 0. Ooh, did I? No, I didn't. Set the argument equal to the base. Let's use the base first. What's the base? 3. Heads up, 0 doesn't work because you're never going to get 3 to some power to be 0. You cannot use it. That's our asymptote when the argument's 0. But check it out. Can I solve this? What do we get for x? Now, again, I want to make sure that we all grasp what we've just done and why this is so important. At this point, I'm going to put the bars on my table real quickly. Okay, there's no additional thought needed. What we just worked out is that if I choose -1, what does it make my argument? Don't plug it in to do the work. We made the argument 3, and this is the x it gave me, which means if I plug in that x, I get this as my argument. We don't have to do the problem twice. Now, I'm going to show... Did I lose you there? Okay. Your face would make me think otherwise, but I believe you. So let's just do a little bit of scratch work, which I think most of the time you can do it in your head. What's log base 3 of 3? 1. Now check it out, because everybody wants to panic and pause with that question. Just change the question in your head. I try to not ask it so it leads you. 3, my base, to what power equals 3? 1. And that's all you need to think about with the log. So this is as simple as doing, what's 2 times 1? -1. I know that the order pair -1, 1 is on my graph. Okay, I'm going to switch color and we're going to do a different one. I need my argument to equal the base. It's already done. What's something else I want to make my argument equal to? 1. Deal. When I do this, what do I get for x? -3. Now, what that means to me is when I write a -3 here, and I suppose I could keep red, without having to do any additional thought, I now have 2 times log base 3 of something minus 1. And our scratch work just now says pick -3 if you want the argument to be what? I already know it's 1. We've done that scratch work to be able to do this. Okay, this thing, just a number. 3 to what power gives me a 1? So this becomes 2 times 0 minus 1. 2 times 0 is 0. Minus 1 is -1. We got another ordered pair here. Okay, I want you guys to do the last one in this lovely dark blue color. X plus 4 better be equal to something. I'm going to give you a moment. 3 to what power is 1/3? So this is 2 times negative 1 minus 1. Negative 2 minus 1. Negative 3. Right? Negative 2 minus 1 more. Your homework that I will check tomorrow, it'll be a 1-point assignment. You need to graph these 3 points. Find me the vertical asymptote. You need to graph them, and then you need to tell me the domain and range.
Okay.
Vertical asymptote by setting the argument equal to what? 0. Argument equal to 0 here. Then domain, range, and graph. 1 point on the line. Cool. Do it.